Hello everyone, allow me to introduce the string pooling system, a training system that automates the rehabilitation training and evaluation for lab animals in skilled movement tasks. Our design team consists of Ang Li, Xuan, Maocheng, and Ruichen Chen. Our client is Dr. Fenrich. The string pooling system is a portable module designed specifically for laboratory usage. Once integrated into the training enclosure, it motivates lab animals to complete the training goal. That is, if the target pulls the string vigorously for several centimeters, a food reward would be automatically dispensed. Meanwhile, the researcher could configure the experiment parameters while monitoring the entire process through the web page the system hosts. The previous approach for the training is usually done by manually tying food rewards to the string ends. However, the original setting requires tedious preparation. We hope the deployment of our system could greatly reduce the time and money cost of such training experiments. Allow me to introduce our web-based graphical user interface. Once the Raspberry Pi connects to Wi-Fi, any device under the same local area network has access to the website the system hosts. You are only required to have the Raspberry Pi IP address, which could be retrieved by running some free IP scanning software on your PC. In my case, the IP address is listed here. The port number is always 5000, so let's go to the website. The first page is the login page. We have not decided the user restriction rule yet, which means that anyone could access the string pooling system for now. If you are a new user, you just need to create a new account. The next page I'm going to introduce is the configure page, where you could write experiment information and training settings. We store the training settings separately, so you don't have to re-enter the same value every time you start one new experiment. The next page I'm going to introduce displays the real-time data. Since we have not started the experiment, the current reading are all zeros. You could also interrupt the undergoing task. The last page I'm going to introduce is the database page, where you could review the previous recording. To query one piece of training data, the animal ID and the experiment ID is required. All the records is shown here. You can either download the data as CSV file or delete the data.
Here is our string pooling system. It has a string, a pulley, a motor that is attached to the pulley, and also a load cell here, which can measure the force that is pulled on the string. The users can set the training parameters on the website. Once the pulling force on the string is greater than the value required, the motor starts to remove. And once the string is pulled for a certain distance, the dispenser will drop food pellets for the training animal. Here you can see is our food dispenser. It has a rotating floor, a motor which drives the floor, and also an optical switch here. The optical switch is used to detect the food pellets dropped through this nozzle. You can see here are some small holes on the floor of this dispenser. These small holes will bring the food pellets to the nozzle and drop through it. When there is a food pellet detected by the optical switch, the motor will stop remove. Otherwise, it will keep rotating unless there is a food pellet dropped through the nozzle.
So now I'm gonna show the full demonstration of our device. As you can see here, we will first set up the training parameters for our device, including the experiment ID, subject ID, date, duration, comment, and the training setting ID. By clicking the submit button below, it will automatically generate the training setting data below and upload all the configuration to the Raspberry Pi. You can also make changes to the training setting by clicking the upload button. So now we are starting the task. We can view all the data on the web server side. And now we are gonna start by putting a load of 10 grams. The device will soon detect the load and send the data to the server. Also, since the load hasn't reached the target of 20 grams, the pulley won't move. Next, we are gonna change the load to 50 grams. It should be larger than the needed target force of the pulley, and the pulley will start rotating. When the pulley finishes its target turns, it will stop and the food dispenser will start to function and drop food rewards. When the optical sensor interrogated in the food dispenser detects a successful food drop, the dispenser will stop spinning. And now let's set up another task to test the interrupt function. We put a 50 grams load onto the pulley and it will start to rotate as expected. Now when we press the interrupt button, the whole task will stop. So that is the full demonstration of our working device.
The previous demo shows the main features of our prototype. They are the web server, the pulley system, and the food dispenser. The web server is able to modify the training setting, monitor the training data, and store the training results. It allows us to control and manage the training environments. The pulley system is able to adjust the pulley speed according to the force applied on the string. According to different force, it will accelerate or decelerate the pulley. Last but not least, the food dispenser is able to dispense food automatically and precisely. However, there are still some limitations inside our prototype. Firstly, the string sliding on the pulley will cause the speed and distance measurement incorrect. Second, the stepper motor's roll torque will greatly limit the maximum force that we can use to train the little animals. Next, the dispenser will get stuck by the pellets slipping into the gap. Last but not least, some training data stored inside the database will not be able to display correctly on the web server under some scenario. To address the hardware limitations, our team's suggestion would be changing the hardware components. For example, changing a better stepper motor can solve the roll torque problem, and changing the material of the string and the pulley can increase the friction force between them. And by doing that, the sliding will be no longer happen on the pulley. For the software limitations, our suggestion would be spend more time to debug and try to use another tools to display the database. Our prototype matches all functionalities requirements as an automatic string pulling device. However, it still needs to be tested by real laboratory animals. And even though it passed the real animals test, it still has a long way to go. Therefore, the string pulling team will try to make the code more portable in order to allow convenient hardware replacement and software improvement. We sincerely hope that Dr. Fenrich and his team can make this device successfully in animals rehabilitation. Thank you for your time and hope you can enjoy the rest of the presentations as well.